So here's where we begin. The probability of a jackpot in any draw is 1/60th, okay? By the way, just as a side note, please avoid just writing this all over the place, okay? Because in all kinds of questions, and this is a perfect example, you're gonna have to consider many different probabilities, and you want to be able to distinguish them, right? So don't just call them all P for probability. It might take you that extra 10 seconds to write out something descriptive, right? But then you can know what's going on and you don't get mixed up in, I've got 5 different values for P and I don't know which one's which, okay? So, don't do that. Let's wrap that up. This is the jackpot in any draw on any given event, okay? So the first question is, what's the probability that the jackpot prize will be won in each of 4 consecutive draws? 4 consecutive draws. Okay, so let's think about this. We've got in our toolbox these 3 basic ideas and they go together in all different combinations and gives every probability question that exists. Product rule, simultaneous events, addition rule, non-simultaneous events, and the complement, when you consider something's opposite, okay? Now when you've got a win in 4 consecutive draws, which one does this feel like to you? 4 consecutive draws. Now, remember, we started off by having a think about how you can illustrate this, okay? So, which of the tools, listing, sample space, sorry, not sample space, a dot diagram, and a probability tree, which would be most helpful to you in this situation? I think the tree diagram would be most helpful, okay? Because the sample space, it kind of already breaks down, sorry, not sample space, I keep saying that, dot diagram. The dot diagram already breaks down when you see this. You see that? That means dot diagram's out, okay? Listing, by extension, right? Listing is worse, it's simpler than a dot diagram. So like if the dot diagram is a dud, then the listing is probably also gonna be done. So automatically there you go. Now, what kind of tree diagram do you draw? Here's a bad tree diagram to draw, okay? How many, the probability is 60, right? So 60 different, I could do this. Hold on, that doesn't look like it's enough. Hold on, let me do a few more. Okay, right, so I could do 60 different branches and then I can have one up the top. Hooray, okay? Now that's a silly way to do it, obviously. What would be a more efficient way to construct a diagram that would be useful? All I'm interested in is, do I win or do I not? That's all, okay? So you could say, I will get rid of my silly diagram here. You could say win or lose, right? That'd be fine, okay? But using the language that we've developed already, I think it's smarter and more concise to say win and not win. That's all, okay? All right, what are the probabilities on it? A 60th and 59 60ths, okay, no problem. Right, now if I want 4 consecutive wins, okay, I'm already only interested in one of the branches. Which one? The top one, okay? So I'm just gonna forget about this guy for a second because he is no longer useful to me. And I say, well, this happens. And then I draw again, right? Win, not win. Okay, now think carefully. What's the probability now? For these 2 branches, it's still 1 over 60 and 59 over 60. It's still that. And the question tells you, what's the key word that tells you? Any draw, good. A single word tells you there's no change here, right? So in a real sense, these 2 things, these 2 events are independent, okay? By the way, this is the gambler's fallacy, which is like, oh, well, if I, say if you're going down this way, it's like, I lost, and I lost, and I lost. I'm more likely to win next time, right? Because I've lost so many times. It's a lie. You look at the numbers. Every time, it's completely brand new. Okay, so you win once, or someone wins once. You win twice. What have I got to keep? Okay, at this point, you're starting to see the pattern, okay? Again, I'm not interested in this. I'm going to branch off up here. It's still going to be the same. Right? This is 1, 2, 3 times, you got to do it one more. I'm not going to bother drawing it. You can see what's going on. I need this, and the next one. All simultaneously. right? So what am I going to do? I'm going to multiply it, right? So this will be 1 over 60 to the power of 4. That's all. Okay. I know what 6 cubed is, but I don't know what 6 to the 4 is. Can someone tell me what 6?
1 over.
1 over?
12 million.
Yep.
960,000.
960,000. Yeah, sure. That looks about right. 316. Yeah, brilliant. Okay. So in other words, not very likely. But there you go. Of course, it's not very likely. Even one of them happening was not likely.